Okay, so someone messaged me on my Instagram, which you can follow, by the way. I'll have my somewhere down in the description. If you have any questions, then I can try to help you out with them. In this case, somebody had a physics question regarding a pulley with a two-mass system. And he's like, hey, can you help me out? And I'm like, sure, absolutely. Just send it to me and I'll see what I can do. So this was part of it. I'm going to try to do all of it. Maybe I'll break it up over the weekend because I just got home from work. But we'll start with the pulley question first. So basically, I know the image isn't great, but we have this pulley system, and we have these two masses, mass 1, mass 2, which are given over here. And basically what it wants us to do is find the acceleration and the speed of mass 2 after 10 meters. So I'm going to start, I'm not entirely sure. I think he said he was in high school. So I'm going to try to go over a good chunk of this. There's different ways to approach this. And if this is your first semester in physics, you're probably going to want to treat this as two individual objects, which makes sense. You have two different masses. But you can also treat this as a system, and I'll show you that later. But let's do it the way most people would do it if they first saw a problem. And we'll start this problem the way we start most. In this case, they draw our picture, they give us our given. So, free body diagram. Good place to start usually. So what does our free body diagram look like? Well, let's look at mass 1 first. And let's just draw here. So mass 2 is bigger than mass 1. So I think it's safe to say we're going to have acceleration like this. That's our direction of acceleration. So mass 1 is going to feel two forces. The first is the force due to gravity, exerted onto 1, which is just equal to m1g. And it's going to feel a tension force. Now, why is it feeling a tension force that looks much bigger in magnitude compared to gravity? Because there's acceleration. And because there's acceleration, we're going to have unbalanced forces. In this case, our unbalanced force should skew in the direction of acceleration. So this is for mass 1. And for mass 2, we'll see something else, except its acceleration is down. So our net force should skew in that direction. There is a tension force, but it's being, I guess, overwhelmed, you could say, by the force due to gravity. Okay, so we have our free body diagrams done. Now we go on to Newton's second law. So we could look at either one, but let's look at the first mass first. So the sum of all forces, in this case, there's only motion in the y direction. I'm not going to specify it, but just so we know, there's no x direction. The force on 1 is equal to mass 1 times the acceleration of 1. And likewise, I could do the exact same thing for the second block. And I'm going to use this to tell you guys something. Acceleration 1 and acceleration 2 are going to be equal to each other. Why is that? Well, if this block, let's say, goes down 10 meters, this mass has to go up 10 meters. For this mass to drop 10 meters, it's going to have to be given 10 meters of string. Well, where is it coming from? It must be coming from here. That's the only other place there's string. It wouldn't make any sense if, it's just coming out of nowhere. It has to be coming from here. So for M2 to be given something, it has to take it from mass 1. Okay? So hopefully that makes sense, and that makes sense on why our accelerations are the same. So, okay, now that we know this, I'm just going to call it acceleration. I'm just going to call it A. So let's look at force 1. what forces do we have acting on 1? Well, we just have to look at our free body diagram, right? We have tension. Let's draw it a little lower. We have tension minus mass 1 times gravity equals m1a. And we can do the same thing for the second one. What do we have? Well, we just have to be mostly careful with our signs here. We have mass 2 times gravity minus tension equals m2a. Now the signs may confuse you a little bit. The way I'm looking at it is which force is helping us accelerate. So if we look at block 1, which force is pointing in the direction of where we're accelerating? Well, tension, right? So for that reason, tension is positive, and our weight force, which is opposing where we're accelerating, is negative. If we go over to mass 2, we see the script is flipped. The force due to gravity is what's pointing in the direction of acceleration, and tension's actually opposing our acceleration. Okay, well, this is kind of one of the issues we run into here when we don't treat it as a system, is we have a system of equations. We have 2 equations and 2 unknowns. Tension, which, just so we're clear, tension here is the same as tension here, which is the same as tension here. It's uniformed, is kind of what I'm saying. So both tensions are the same. We know both masses, we know gravity, but we don't know the acceleration. And both accelerations are the same. So this isn't too bad. Tension equals mass 1 times acceleration plus mass 1 times gravity. So pretty easily we're able to find an expression for tension. Now, that's great, but we don't know acceleration. So we can take this and plug this guy right into there. And what do we get? Well, mass 2 times g minus m1 times a minus m1 times g equals m2 times a. Okay, so instead of tension, I just plugged in what we have in orange, which is this part. This was our tension. I just substituted it in and distributed this negative. So this negative. Okay? Well, if we want to solve an equation, we have one equation, one unknown. This is straightforward. All we have to do is get our unknown on one side. So I'm going to add this to both sides. So we're left with m2g minus m1g equals m2a plus m1a. On the left-hand side, I see both have a g. So I'm going to factor out a g, and I'll get g times mass 2 minus mass 1 equals, both have an acceleration, so I'll do the same thing there, m2 plus m1. Dividing both sides by m2 plus m1 divided by m2 plus m1. That goes away. And we find the acceleration of the block is equal to g times mass 2 minus mass 1 all over m2 plus m1. And all these are known. We know the mass and we know gravity. I'll let you guys plug that into the calculator. Okay, real quick, I want to show you guys how much easier this is if we take a little physics trick and we treat this as an entire system, which includes mass 1, mass 2, and whatever you want to call it, I guess the Pulley system, even though that wasn't really So now we can say our acceleration, the magnitude of our acceleration, is equal to the sum of our forces, and we'll just say total, over mass total. Now, maybe this looks a little weird, but all this is saying is the net force acting on both the block 1 and block 2. Well, it's pretty much the exact same process as before. We say what forces are acting on block 1, and if you remember, we said, minus m1g. Same process. Minus m1g. We said there was a force due to gravity on the second block, so plus m2g. That's positive because of the direction. We also said there was tension force, but here's the trick. Yes, there is a tension on both blocks feel a tension force. However, if we think of it in the grand scheme of things, this tension right here is pointing in the opposite direction of this tension here. And we kind of have this relationship where your tension is an internal force. It's not external. It's not something that it's going to be felt by the entirety of the system. So we don't have to include tension within our summation of forces. It's not one we have to look at. And then the mass total, pretty easy. We just add mass 1 plus mass 2. And if you wanted to simplify it and just write it the way we wrote it earlier, acceleration is g times m2 minus m1 all over m1 plus m2. And you see that this is the same as what we got above. Just noticeably easier if you're okay with the physics. If you're not, you can do it this way, but you're going to have to work with a system of equations. Nothing wrong with that, it's just something you're going to have to do. Okay, so tension, they wanted us to find tension. Tension, we said was, well, that was up here. I highlighted it in orange. Mass 1 times acceleration plus m1 times g. But now we know acceleration, right? It's literally right there. So we can say tension is equal to mass 1 times gm2 minus m1 divided by m1 plus m2 plus m1g. I'll just go ahead and distribute it because why not? We have m1 times m2 times g minus m1 squared g all over m1 plus m2 plus m1g. Don't think that really simplified it much, but, whatever. Here's your tension force. Honestly, it'd probably be easier just to get a number for acceleration and then just plug that number in. I'm lazy and I don't have my calculator on me, so I'm not getting an exact number. But that's an easier way to do than the expression. The next thing it wanted to know the velocity. Well, let's do a different color. We've done this one, but it's fine. The velocity after 10 meters. Well, notice that your acceleration is constant. If we look up here, g and your masses, those are all constants in this case. So your acceleration is constant. Acceleration is constant. And if you see that, you should think kinematic equations. In particular, we're going to do velocity squared equals v initial squared plus 2 times acceleration times delta y. Now, I'm assuming that the system isn't moving, So that's just going to be 0, at least not to start. And then we can say velocity is the square root of 2 times your acceleration times your delta y, which the delta y is 10. Acceleration we just found, again, a lot nicer to just, instead of putting this under the radical, just get a value. And this is going to be the velocity of the block after 10 meters. So hopefully that makes sense. And depending on if you want down or up to be positive, that'll indicate your direction. So obviously the pulley is moving down, so maybe you let this be positive. It's up to you. But that's your number. That'll just dictate your sign. If you let up be positive, then this is going to be a negative number. You're going down. So yeah, there you go. There's how you solve the pulley question. We found the force, the acceleration, the tension force, and the velocity. So that hopefully will get you started. And then he gave me another, I think he had the second question. I didn't look at it, but if he needs help on that, I'll help him. And I think he needs help on the back page. So maybe that's what the next video will be. All right, if you guys need any help, you know where to message me, and hopefully I can help you.